Hello guys, I'm back, Patrick from the Backyard Science Lab, and today I'm going to be simulating something on one of my favorite games, Kerbal Space Program. I've put a lot of time into this, and it's going to help me demonstrate a thing that I've been thinking of recently about SSTOs. And SSTO means single stage to orbit, but today I'm really just going to be talking about how high they can go and this single stage factor. And I made the closest representation to my paper V6 rocket I can, where I put a pod down with a parachute, a structural thing just as the paper part that has no engine in my rocket, and then finally the smallest engine. And while this is a little bit put up from my paper V6 rocket, it's the closest I could get, and of course I put a couple fins on. And I'm going to launch this and show you how, if I keep making these engines bigger and bigger, it will never become a very good rocket. And this is loading now to when I launch it. And sorry if this video quality isn't very good. This is my first test with this capture software, with this new recorder and new editor. As you can see, we're launching and our rocket has died out. We're just cruising up and then till we should deploy our parachute. But yeah, tell me how good this, if you like this Kerbal Space Program video. If you want more, I can do a series on this, or just random really cool creations in this. But we are dropping now, and I'm speeding this up so that it doesn't take too long. But now we are about to land. We're landed. And now I'm going to put one more rocket stage up from this, which is the Hammer solid fuel. And I should say that these are all solid fuel rocket engines, so I cannot control them, unlike the liquid fuel rocket engines. And this Hammer one is a little bit bigger than the last Flea one, and it will give a little bit more power. This is kind of representing our B rocket, I guess. I'm putting my fins on. The fins, while they do show, and I do have fins on my paper V6 rocket, they give a little bit more stability in this, since I don't have any gimbal or control over these solid fuel rockets. And you can see this has 1,400 meters per second of delta V, a little bit more than the Flea. You can see as I go up. I'm going pretty high right now, but I have a very, very low payload. I'm just bringing that one little pod. I kind of forgot to put a decoupler in, so yeah, this is kind of doomed. But we're descending. This definitely went higher than my other one, although, yeah, it went higher. Although I wasn't able to land it because I forgot and it weighed too much for the parachute. But anyway, on to the next one, which is, and I'm going to put a decoupler on this time. I got the separators this time because they just look a little bit better and fit nicer. Although I do recommend the yellow ones better. And this is the Thumper, I think. And yep. So I'm remaking this rocket. This is pretty much like the C engine of Kerbal Space Program. And if you don't know what I'm talking about in any of these, go look at it was my third video I did, flying a rocket that I did IRL with different solid fuel engines. And then my first video I ever did was explaining the rocket, if you want to see any of those. So now I decoupled and you can see the pod. I forgot to do this in daylight, but whatever. And now it's entering. You can see it heating up as it re-enters, and the parachute deploying. This was a pretty fast entry because I was out of the atmosphere. And we have just about landed. So now I'm going back to the rocket center to build and put the last engine on, the last solid fuel rocket on, which is the biggest one. And while this one doesn't really have a real-life comparison, I guess you could say a D rocket, but I'm going to fly this one and show these. And then I'm going to go into and I'm adding more parachutes because I know this one's going to go higher. And you can see the stages on the side. If you've never played Kerbal Space Program, you can see stages and how I blew the rocket, and then this separator, and then the parachutes by pressing spacebar. I'll just be quiet a little bit while you watch this. Sorry it's not brighter. I know it may be darker because YouTube always makes everything darker. But those drogue chutes that I put on, which are those 4, are smaller chutes that can take more heat and speed. So those deploy first, and to slow it down a little bit, they're like pilot chutes that you'll see on real rockets, and then the big main chute will deploy. So the next thing, I'm going to be trying liquid fuel rockets. And you can see this is one of the higher liquid fuel rockets, and it gives me a lot of speed, although it's not very efficient, because it gives a lot of speed, and it's for larger payloads and stuff. But as you can see, I drop, and I'm still not going very high, and with these engines and these rockets, it's getting pretty expensive at this point. And now I put on the Mammoth, which is the highest rocket, and I only put a couple fuel tanks on. I probably could have put a lot more in. That would have helped a little bit getting it higher. But as you can see, the Mammoth burned through the fuel so quickly that it just kind of didn't go as high as the other ones. Although gave a lot of speed. As you could see, it was starting to burn you could see the fire coming off of it. Yep, I'm dropping now. Speeding it up with the time warp here and getting my pilot chutes ready. You can see that when they're white, that means that the pilot chutes in the thing are white. That means that they're ready to deploy, and that it's enough that they're not going too fast to deploy. So you can see the pilot chutes deploy, and then if I were to put up back up, yep, you can see the bigger chute deploying. So now after all this, these are very expensive rocket engines that cost way more, and they didn't go very far. And you'll know from normal rockets that are not SSTOs about different stages. And this is what I'm going to show you now, how more efficient this is. So I'm going to put on a mainsail, which is just about a medium-ish engine for heavy lifting. And then I'm going to put a second stage, where I'm going to decouple a stage where it's a more efficient engine for the higher altitudes. And we'll see how this launches. And I'm putting the Poodle engine on because it's a more efficient engine. It's a more efficient engine, and it burns less fuel less quickly. So you can see I'm putting the lesser fuel tanks on that aren't as wide. And then I'm messing with the stages there to make sure that everything goes in the right place. And you can see now that in my first stage I have over 2,000 meters per second of delta V, which is really good. And then you can actually see in my next stage the delta V is climbing because of the weight that's being dropped by the fuel burning. And once I decouple, I think I have just over 2,500 meters per second of delta V to play with in the second engine. And that's, well, just a little bit under I'm seeing now. And that's really good because then I'm almost fully out of the atmosphere, and now it's like having my first stage again. And you can see that with the other ones. This is even a cheaper rocket, less weight, and I could probably put a much higher payload on. And you can see that my apoapsis is going so high it goes even out of Earth's gravitational field. Sphere of influence, and I'm going to talk about that in a different video because it's pretty interesting. But since we leave no Kerbal behind, I am of course making our apoapsis a little lower. Our apoapsis, if you don't know, is the highest point where we can where we're projected to go. So we're falling back to Earth. I didn't realize how much speed I'd have. I could have put more air brakes and parachutes and all that on, but yeah. So it comes in a little bit too quickly here, but you can see how high our apoapsis is from this map view and where we could have gone if we just kept going, which is much higher than our other engines and is one of the cheapest so far, except for like the flea and hammer. So, but then I'll slow it down. Fireworks happened. So that wasn't the best landing, but you can see from that little demonstration how these rockets would play out in the real world. And I do want to say that Kerbal Space Program is not the most accurate thing, because the gravity is much lower, so that it's actually a fun game to play. You can see the cost and weight there. But yeah, if you like this video and want to see more, subscribe and like. If you want to see more of my Kerbal Space Program videos, comment down in the description. I can do normal playthroughs of this game, or just bigger, cool rockets. And of course, if you have any questions, comment them down below.